So now we're going to hear about using TRSE for development for retro computers by Zarko.
Okay, hello everyone. I am the guy in that room with weird computers that organizes that part of the conference, and this talk is about writing games programs for those old computers. So, first question is, of course, why on earth would someone spend time doing something like that? If you are of a certain mindset, that mostly means interested in retro computers, then writing stuff for those machines is quite fun. At least for me, I am that kind of a person. It can be frustrating, but that is the thing with any kind of programming. It can be very challenging, mostly because those machines have, let's say, completely different specifications than anything that is in the use today. It can be quite fulfilling. It is quite satisfying making something for the electronics that is 40 years old and doing it right, and then that electronics do what you want to do. And of course, 99% of the time, doing something like this is absolutely and utterly commercially failure, useless. You won't get any money out of it, but it's fun. If you try to find, for example, on the itch.io, where a lot of indie developers put their games, where you can buy them, if you search, then you will find that there are many, many games made for retro computers. So that is that 1% where you can make some money if you make game good enough that people would pay. But on the other hand, a lot of developers decide to just release their games for free, and they're mostly happy if anyone just downloads and plays that game. So, what are the tools that are used today to develop programs for such old machines? The usual thing that is really not new is using cross-platform tools. What that means? That means that you develop program for one platform on another platform that is usually more powerful than the one that is the target system. As I said, that idea is really not new. It was used even in the 80s when software houses or software companies, they were called software houses at the time, developed, for example, games for Commodore 64 and ZX Spectrum on much stronger machines like PCs, like Atari STs, Amigas, and so on. Famous example is that game Doom is really not developed on the PC, but on the Next Cube, which was at the time simply a more powerful machine. So the idea of using some other systems to develop something for the less powerful one is something that is used quite often in the last 40 years. And I guess it was used even before, but I am dealing with retro computers from the 80s, and this is where I stop. Regarding, let's say, the retro computing scene, roughly starting in the 2000s, there was emergence of a lot of new hardware for those machines, a lot of new programs, and a lot of new games. And more or less exponentially, starting from 2000s, you get each year more and more releases for various platforms. For example, just for the Commodore 64, there are usually between 500-600 and 1,000 new releases made each year that are games, programs, cracks, music, pictures, and so on and so on. But there are a lot of games, of course. So how do you develop for those machines? In the old days, there were, of course, some development tools that, as I said, were running on a more powerful hardware, or there were tools that run on the target system itself. For example, you had assemblers that run on the Commodore 64 that generate code for the Commodore 64, so you would develop everything on the Commodore itself. From the 2000 onwards, a lot of those tools got improvements. For example, you can use memory expansions to save your code somewhere where is not the main memory of the computer. So when you mess up something in the main memory, you can easily just go back to where you were before. And that is, of course, connected with developing of new hardware. Besides those improvements to the old tools, we have newly developed tools for various systems that you could use to develop programs for those machines. And one of those tools is, of course, the main subject of this talk. All those tools can be roughly categorized in several categories. By host platform, there are a lot of tools that run only on Windows, unfortunately. But there is, let's say, far amount of those that are made cross-platform, meaning they can run on Linux, Windows, or OS X. And just to fill the category, we all have, as I said, all tools that run on the target systems itself. For example, the Amos for the Amiga and so on. Regarding what is the target platform that you are developing for, there are, of course, some tools that output for a single machine. For example, Scorpion engine for the Amiga. Or you have some tools that you can use to develop for the range of machines, like TRSE, that has support for more than 20 platforms at the moment. By interface, we have a tool that you can use from command line. And of course, the good thing about those is that you can integrate it into modern IDEs. For example, VS Code, Eclipse, or whatever you want. And there is a category that has GUI, where you have complete integrated development system with editors, usually text editors. You have editors for the graphics, for specific systems, and so on. If you look at programming language that is used in those, with these tools, two main categories are basic, where we have usually some enhancements to the original basics that you can use to write games and demos. And usually you have some kind of compiler, basic compiler, that can translate that basic code into machine language, so it does not execute in basic interpreter, but directly on the CPU, and thus much faster. For all the retro machines, you usually have some kind of assembler where you can write assembly code on PC and then compile it for a target platform. And there is, let's say, third category that uses different kinds of languages. We have C compilers that target old CPUs, Pascal compilers, and various other tools that use their own custom script languages. And those are usually tailored to the target system. You cannot see most of those. It's really, really tiny letters. I have a document with this, will be shared for the conference. But this is just a rough list of the cross-platform tools that are available today for various platforms. Some of them are for one platform only. Some of them target multi-platforms. Our TRSE that I'm talking about is somewhere here, but as you can see, there is a lot of tools available at the moment. What are the challenges of doing something like this? First, even for the people that were active in the 80s in writing games and programs for those platforms, going back to something like that after 30, 40 years can be challenging because you simply forgot how to deal with those machines, how to deal with that hardware. In some way, it is maybe more or less the same if you never programmed those computers, or you programmed them 40 years ago and forgot everything. So learning about that hardware platform, how it works, how its graphics is organized, how it produces sound, is something that you need to simply spend some time on to be able to use those capabilities the best way you can. Tools, of course, some are familiar to today's tools. For example, if you choose to do something in a C compiler for the old CPUs, then if you know C, it will be more or less easier for you to get into that. But if you use something that uses custom scripting language or Pascal that many of you just heard as a language used in more or less academia, and Delphi IDE somewhere in the 90s, if I remember correctly, then you will simply need time to go into that language. Next challenge is, of course, extremely limited resources that you have available when dealing with those platforms, and those limitations were quite severe even in the 90s for the computers made in the 80s. What that means? That means that you usually have around 64 kilobytes of RAM, that you usually have a CPU that runs at about 1 to 3 megahertz. And why is that limiting? First, you, I don't know, open a web page. One picture on that web page could be several hundred kilobytes, and you have only 64 for everything in those machines. And regarding speed, I mean, you know that today's PCs run in a gigahertz range for a very long time, and having something that runs on 1 megahertz is slow even for today popular small microcontrollers. They are even order of magnitude faster than those retro machines. And maybe, okay, one more hurdle. I cannot say that it is the biggest one, but it is quite a big. And that is if you want to make something that looks like a commercial product. If you want to make a game that is something that will, at least people from the retro community, move their head and say, this is nice, then you will need to learn assembly for the target system. Why? Because only with assembly you can pull everything you can from the hardware regarding speed. Using a higher level language, of course, involves compiler. Compilers usually have their own ways of translating higher language into assembly. But for a human, and for example, compiler has one way to transfer loop to assembly code. But if you're a programmer in assembly, you can implement that loop in assembly in several different ways. And one of those ways, for example, can be more suited or faster for the concrete thing you want to do. So this is something that compilers usually cannot help you. If you want to get more speed, you will need to learn the assembly. The good thing is that you do not have to write the whole thing in the assembly, but you can concentrate on the more critical parts to be done in assembly and less demanding stuff to be made in the higher programming language, and that is something that is a good balance between, let's say, the final speed of the code and ease of programming. What are the rewards? First, you can understand complete computer architecture from bottom to the top. That means you can really understand how every chip in the machine works, how everything is connected, how the software of that machine works, and how the picture and sound are generated in the end. This is usually something that you cannot do with today's PCs. They're simply too complicated. Those machines are relatively simple comparing to today's standards, and you really can, in a, I don't know, month maybe less, understand completely how that thing works. And it is a really nice experience to learn something like that, because even today PCs, although they are much more complex, they are working on the same principles as those old machines. So in that sense, really nice learning experience to know how a computer works. Next thing is, of course, to prove to yourself and to the others that you can actually make something meaningful in that, with that limited resources, so that you do not need a mega powerful PC just to run your PC, just to run your code and then to say, wow, how it looks great. Okay. One remark that you can find, I think from the 19th onward, I don't know when it appeared, says that hardware is cheap, programmers are expensive. Meaning that PC hardware is starting from the 90s, getting cheaper and cheaper and cheaper, and the time that when you need to develop something, it is programmers' time. That is the thing that is expensive. Hardware you can always buy for cheap for him to work on. When that does not translate actually very well to the retro computers, because depending on the target system, that system can be very expensive, or in the other cases simply unavailable, which is, for example, case with the Team 011 computer. Marko and I had a talk about that computer 2 years ago, if I remember correctly. We were analyzing how that computer works, made some software for it, and the thing is that if you want to write something today for that computer, more or less your only way to test your software is through emulation, because there are maybe 10 surviving pieces of that machine, no more. Other problem with old computers that they simply can break anytime. It is simply electronics that is around 40 years old, and as someone who collects computers like that, I might say that I am usually amazed that most of those stuff still works, and I am happy that most of my machines are actually usable and you can use them in the retro room. Making a program for the old computer and running it in the emulator is fine, but if you have the chance to put it on the real machine and run it there on the real hardware, at least for me, that is something very satisfying, more satisfying than seeing it on the PC screen. Now, regarding that availability, there are emulators for, I think, almost all imaginable systems. So you can really start coding for any of them, and those emulators are mostly free software. When you talk about emulators, we have emulators dedicated for one single platform. For example, we have many emulators that target C60 popular computers, C64, ZX Spectrum, or popular old consoles like Nintendo, Sega, and so on. But we also have multi-platform emulators that can emulate many systems. For example, MAME, which I think is the main force behind the arcade cabinet that you have in the hall, where you can play various arcade games. Some of development tools are made to work with some specific emulators or have those emulators integrated into whole IDE, while others have ways to have configuration where you can say, okay, I want to use that and that emulator for that platform. It runs like this, parameters are like that, and so on. Now for the main part of today's talk, that is Turbo Rascal syntax error, or TRSE in short. Why that name? I don't know, ask the author. It was something that came up to his, actually the whole title is a bit longer. I will let you to find it yourself on the site if you want. And what is TRSE? It is a complete IDE that includes compiler, programming language suited for the retro computers, a resource editor, meaning editors for graphics for various formats, and it is intended for developing code for 8 and 16-bit processors and systems that use them. Its language is based on Pascal, but it is not it's not pure Pascal. It has many additions that are not really Pascal-like. We will go through some of them later. Of course, as you often need assembly language can be easily integrated into your code. The thing that is interesting with this environment is that its author spent a lot of time on the compiler for that tool, and compiler generates really well optimized code for the several 8-bit CPUs. What that means? That means if you look at the assembly output of the higher level constructs, you will see that they are almost optimized by hand. Of course, you can make better, but it is usually quite good enough to make, for example, game that does not lag. This is how the environment looks like. We have the main window for the code. There is a part where you have all the files that are in the project, some main commands for running code, saving, and so on. And this is the output of the build system. So it looks more or less like any other IDE. We will now go. I do not intend to go into many details, just speed walk through to the Rascal language. We have usual types for the integers, strings, pointers, addresses. We have support for arrays, and then have some special, let's say, types that are used. For example, IncBin is used to include some binary into your code at the place you want. For example, a lot of old games needed to have a piece of code, then graphic data, then again piece of code, and so on. So you could insert any kind of binary anywhere you want. And on top of that, you can define your own types and use them in your code if that would make your whatever you are making more readable. Then something that is closely related to types are type modifiers that are used to They're usually platform specific. For example, chipmem type modifier says that you want some data to reside in the chip memory on the Amiga computer, so this is Amiga only. Or you can say that some data is needed to be in sprite RAM for the Game Boy, and so on. These are just examples. Strings can usually have null terminator like C, so it's not Pascal strings but C strings. You can say that you do not want that one. You can put variables at some absolute addresses in the CPU's address space. This is very important because most of those machines use memory mapped I/O, meaning that registers for the graphics and sound are usually somewhere in the RAM address space. So you need to tell it, okay, I want, I don't know, register that holds X coordinate for the sprite to be at that exact address. Because I said that authors spent a lot of time on optimizations of the compiler, if you know what you really want to do with your procedures, for example, you can say that parameters passed to those procedures are not really real parameters, but you want to use global variables for something like that. Why would you do that? Because putting stuff in the global variables is faster on those processors, so you can make a faster code. Pure is intended for use for inline functions. I will not go into details for that. Who is interested can find on the site how it really works. Then we have constants. They are similar to C constants. We have defined where you can, those constants are more or less the same as C define, meaning it is something that compiler will just replace every text that is screen width with characters for 0, the same way the C microprocessor works. You use it for microprocessor, and something that is added later to the language, we have const, and the syntax is more or less the same as you would expect. Regarding literals, base 10, base 16, base 2, base 8, and of course characters or ASCII. Variables are defined the same way as are defined in Pascal, so you have name of the variable, column, byte, and so on. You need to use this symbol to assign a value to a variable. That is really a Pascal thing. You can define arrays. Arrays can be accessed in the way you would expect them to. You can also position arrays at some specific addresses in the memory. For example, defining array in a memory where screen resides allows you to, by writing something to the bytes in the array, to actually place characters on the computer screen. One of the things that is also added to the language is support for generating different tables. They are usually needed for speeding up the code in your program. For example, if you need to place something on the screen on the X and Y coordinates, one logic way is to multiply Y coordinate by the width of the screen. You add X coordinate to that, and you get location in memory where you need to place something. But faster way is that if you have array that has addresses of the old lines already pre-calculated, and then you just add that address to the X coordinate and get everything without multiplying. And multiplying and division is really a sore point in the 8-bit CPUs. So you can generate any kind of tables that you need for your code, and the syntax used for this expression is JavaScript. Then we have pointers that can point to almost anything. You use them the way you would expect. You set pointer to some address, assign value. You can say that pointer is at address of some variable and so on, the same as you have in C, for example. Language also have records. That is when you want to combine several types of data into one entity. But these records are somewhat special, meaning that if you make an array of records, then they are not stored sequentially, meaning you have, I don't know, 10 bytes that hold first record, then you have 10 bytes that hold second record, and so on. They are stored in the way that each element of the record is stored as a separate array. Why is that? Well, the reason is because 8-bit CPUs can really have a relatively fast access to arrays, but arrays of bytes, but have a really slow way to address something that is not multiple of 1 or 2, which is usually records. And the reason why it's done this way is to speed up the code. There is also a class that is more or less same as record, but it stores data sequentially. Because of that, you can have a pointer to something like this, and you cannot have pointer to something like this. And of course, you can make pointer to object of a class, but access to something like that is really slower. Regarding system support, there is let's say common library made for all systems that are supported. But the thing is that that common library is not finished for all systems. Some systems have much better support, some of course not, and the author of the IDE is very interested in getting help for supporting more common platforms. The good thing is that IDE comes with really enormous amount of tutorials that cover the language itself, meaning the features of language that are common for all systems supported, and then it covers each specific system and its, I don't know, sound graphics and so on. And again, number of tutorials is bigger for the more common or more popular platforms. You have less tutorials for the poorer systems. But yeah, that's life. How a program in Rascal looks like. This is just a simple program that clears the screen, then writes something in the video memory, and then makes infinite loop at the end. So if you run this, you will get something like this on the screen of the C64. We can have one number displayed and one string. This is just to show you how a minimal program, how a hello world would look like. Regarding constructs, we have if-else, nested conditionals, but you need to use braces around everything, because compiler does not handle those if you do not have them, so it's not a big deal. We have a case or C switch that has some interesting features, and else. We have several types of loops. One that is actually C loop that runs from A to B minus 1. And we have for I that runs from A to B as in Pascal. Then we have while and usual constructs for exiting the loop early, continue, and break. One interesting thing is a modifier that says unroll. What does that mean? This is something that actually modern compilers also do. If you, for example, want some code to run faster, for example, you have a loop that does something. How that loop executes on the CPU? You have some piece of assembly code that checks if the condition for executing the loop is correct. Then you have the loop body, some assembly instructions that do whatever your loop does. And then in the end, you have a jump back to the condition part where then you again check if you need to run another iteration loop and so on. If you know exactly how many times your loop should execute, one easy way to really speed up the things is, for example, you have a loop that 10 times needs to do something. You can copy that code 10 times, just changing the iterator value through each copy. And this is what actually this unroll does for you. So you make something, code that does something, and just multiply it by however you want. Of course, you get the speed, but you lose the memory in doing so. Then we have support for functions. They have parameters, can be of soft type. You can have local variables and put code inside. Syntax for returning value for Pascal is to assign something to the function name. And that syntax in this language is somehow limited, meaning that you can do that only at once in the function body. But if you need to return to exit function early or return different values, then you can use a special return value procedure that will just exit the function with the value you want. Procedures are the same as void C functions, so same thing, but we do not have a return type. Function procedures can be declared inline, meaning one more way of making your code faster, but requiring more memory. And one thing that is really important for this language is that recursive calls are really not supported. Why? Because the IDE and the language is really meant for developing demos and games for the old computers. In demos and games, you usually, in the probably 99.99 cases, do not need to have recursion or really deep calling stacks. By eliminating this from the language, what was gained is a really nice speed in passing arguments to the function. So we lose some nice things that we are accustomed to in regular programming languages, but we get speed. And regarding old computers, speed is, at least in my opinion, really much more important than having just the ability to do recursive calls. I mentioned that we can put assembly language inside any place in the code, so you write some Rascal, Pascal lines, then you just say SM, and then put some assembly code. Good thing is that assembly code can access any variable, everything you have declared in the higher programming language, so it is really easy to combine the two. As for preprocessor, we have, let's say, usual suspects. You can have parts of the code that can be included in your final executable depending on some rules. There is a support for macros and support for having a code not just in one file, but scattered over some logic units. I also mentioned that this is an integrated development environment that supports graphics for different systems. So we have a character map editor, meaning you can define, let's say, fonts for those machines. Most of those systems actually had used fonts to define graphics that is on the screen. So you have the editor where you can change those. You have image editor where you can edit images in a lot of formats, graphic formats that are needed for those computers. More or less, each computer had its own way of displaying graphics, its own way of arranging bytes that generate the picture, and so on. So editor supports almost all of them. And you have a sprite editor. For those of you who do not know what sprites are, those are small moving objects that appear in the two-dimensional games, for example, spaceships that runs around, bullets, and so on. And you have ways of defining graphics for those too. This is an example of a character editor that is for 8x8 characters. This is more or less the same thing, but for 16x16. This is, of course, a picture of a cat. We cannot have a presentation without a picture of a cat, but this is just an example for the image editor for example, C64. And we have editor for sprites where we can define all those moving parts that actually make the game. What is TRSE used for today? Many demos are made with it. Actually, authors' initial intention of making this tool was to be able to make faster make demos for the C64. That is how it all started. But then capabilities grow and people started using it to write games, and some of those games won awards. And that is the reason why the strange named ID became more and more popular. Many games are written mostly for the Commodore 64, but a lot of games also for VIC-20 and for some really obscure platforms like Laser VZ200 or Team 011 that I already mentioned. Even some utility programs are written with it, but demos and games are mostly what is used for. And here is some of the examples of games that are made with this ID. This is Knight Knight that is made for several platforms. Then we have Candy Crush version for several platforms also made in it. Then we have a clone of the Tron game for 4 players. Then there is a platform game for the VIC-20, or let's say more logic platform game. Some of those games are actually commercial. This is Lester, winner of several awards a few years ago. This is a game for the Laser VZ200 that is a machine with really, really limited capabilities. So the graphics looks like this. This is another game for the same system. This is one game made for the VIC-20, I think a month ago, about a month ago. This is one game made for the Commodore Plus 4 computer. Doesn't have sound, but not all of them have to have sound. This is the Tetris I made for the Team 011, and I entered Revision 2024 contest with it. One small intro I also made in this environment. And this is a program that controls hardware for the Commodore 64 that has several relays, and you can program how those relays are turning on and off depending on various timers, inputs, and so on. Okay, so I hope that you have now more or less image of that, what can be done with the IDE. So the last part of the presentation is to show you some really small and really simple game for the Commodore 64. So game has a big bad enemy at the top of the screen, enemy ship. We have player's vehicle at the bottom of the screen. Enemy is moving left to right constantly and firing at the player whenever it's on top of it. And the player also can move left and right and shoot at the enemy. Game is ended with when either of those gets a hit. So what is our enemy logic? We have coordinates for the enemy ship that can go from 0 to the screen width. Its y coordinate is always the same. We have enemy dx variable that is used to differentiate between going from left to right or right to left. And we have two variables for the enemy's bullet. When he fires a bullet, the bullet goes down the screen and then reaches the end, missing or hitting the player. Player logic, we have controls on the keyboard where we can move the ship left or right, and one key that we can use to shoot a bullet at the enemy. More or less the same thing as the enemy can do. Bullet logic, when we press a button as a player to launch a bullet, it just goes from the position where the ship currently goes upwards. When it reaches top of the screen, it is checked if x coordinate of the bullet is somewhere in the ship, and if it is, the enemy is defeated. The same thing is for the enemy bullet. It goes down, and when we reach the bottom of the screen, we just check the x coordinate against the coordinates of the ship and determine if it is hit or not. How is the game drawing organized? Well, we are using the character screen, so we will draw characters for the entire game. We will draw both ships in the characters, and bullets will be characters also. Code is organized as several functions. Init initializes the game, all the variables. Title displays the title screen. Draw draws the player and enemy ships. Move enemy implements logic for the enemy. Move player implements player control of the ship and also restarts the game after the game is over. And move bullets implements bullet logic and checks if the game is over. Main code of the entire game is something like this. We have infinite loop where if game is not over, we are moving enemy and bullets, then move player or check if we need to restart the game and draw everything. So this is more or less how it looks like. Now let's see how that works in... Oh, I didn't expect... Okay, let me see. So, I can press the space to start the game. Enemy will shoot at me whenever it is directly above the player. I can shoot back. He can kill me or I can heal him, and there is no logic to play beyond this one. It is really simple game. The same game can be also played. I would just do that really fast. It is absolutely the same code. And we can run it also on VIC-20. This is another Commodore computer, but different than 64. But the same code works exactly on that machine too. It looks a bit different, but it is actually the same code. And as the end, I would like to run the game on the Commodore 64 itself. Do we have the screen? Okay. Now I'm going to do this more or less blindly. Oh, okay, I can see. So, moving the sprite on the real Commodore 64, firing at the enemy, he kills me. I'm not really good at this angle at the game. But simple game, transfer to the real computer, and simply works. This one. Okay. That is more or less the end of the presentation. I hope that, if nothing else, made you realize that making something for really old computer is not that complicated as it sounds. I mean, there are complicated stuff if you go into hardware details, of course, but some simple stuff you can make really, really easy. Maybe some of you will be interested to try something like that. I hope you will. As I said, TRSE is not the only environment, but it is something that was really nice for me, especially as the author of the environment was kind enough to add support for really, really, really obsolete Yugoslav computer from the 80s, and I was able to make a game for that computer, a Tetris, that was ranked, I think, 5th on the revision out of 10 entries, and I was really, really happy to see my game running on a demo competition like that. So it was really something really satisfying for me. Questions?
Have you ever tried to overclock retro PC? Is that even possible?
Retro PCs?
Yes.
I think it is possible, but my area of interest is computers that are not PCs. So I'm not the best person to answer you that. To the best of my knowledge, yes, it is possible to overclock them, but regarding other computers that are not x86 based, usually retro community looks very, very critically if you try to make something for a hardware that is not really that hardware, but change in some way that gives it advantage over something that was existing all those years ago. So it is possible. There are projects where you can speed up many old computers, but put in, for example, FPGA reimplementations of the CPU that can run, for example, at 50 or 100 megahertz. And there are really nice experiments, but it's not really supported by the rest of the community. On the other hand, if that is something that is interesting to you, just do it. No problem.
Thanks for the great presentation. I wonder, for the whole programming language and the whole IDE, how is the community organized? Like, how are you communicating? How do you have a Discord channel? Do you have mailing lists or a forum?
Currently it is Slack. There is a Slack channel for that, and it can be really noisy at times and can be really quiet at times, depending on what are people currently doing. So if someone is currently making a game and has problems, then you will have a lot of questions there, and there are people who will answer and post more questions and so on. But usually during summer, nobody is doing nothing, and it's really quite quiet there. And the access to that server, I think, is open. I think there is a link on the main TRSE site, if I remember correctly.
Thank you very much.
You're welcome.
Thank you for your talk. I have practical questions about variables naming. Is it conventional to name variables like P bullet X instead of player bullet X?
That was just something that I made up, I don't know, 2 weeks ago when I made that example. You can use, there is no convention, and you can use any style you want.
Thank you. I think it's more readable if you write entire word.
Yeah, I understand. And this was just a really, really quick example, something that I could make in, I don't know, hour and a half that runs on the Commodore 64, but it is kind of a minimal game. So I didn't spend a lot of time on names. They're just what popped into my head at the time. It could be, of course, much better than the source. And I will leave that source and presentation and the file with list of all the cross-platform tools available to anyone who is interested.
So, by the way, great talk and great effort.
Thank you.
I wanted to ask, like, specifically for the game that you demoed, how does the Commodore machine redraw the screen? Is this something you control in the program, or is it like resolution locked?
Oh, you mean how do you make things change?
Framing,
on the screen?
basically.
The thing is that Commodore 64 has part of its RAM memory is actually video memory also. So if you change the RAM, you're actually changing the picture on the screen. Meaning that, for example, let me just find the draw part. So I just I made a function that it's called print, but that does not really print in the C kind of way. It just put bytes on some place on the video memory. So this actually moves the player left. Prints the player ship or enemy ship at some part of the screen, and the thing is that I defined, let me just, so this is, for example, player sprite, player ship, and if you see, it has space on either side. And because it moves only by one character, if I print just one position to the left or to the right, I will automatically erase old characters and draw it on the new position. So just by simply writing to video memory, I make things move on the screen.
And how do you control the game speed? Is it something that's fixed to...
Yes, it is fixed. So there is, okay, the resolution is small, but there is a weight call that are you familiar with the way the old computers or CRT monitors worked? So you have an electron beam that draws one line, then goes back quickly, draws another one, and then when it reaches the end, it goes back, and that does 50 times a second. So what I did here is instructed the computer to each loop of the game to be synchronized with starting of the screen drawing, which means that game loop runs at, now I'm not sure, 25 or 50 times a second. So it is fixed. And that is how I get that speed.
It's locked to the refresh rate, basically.
Yes, yes, yes. Okay, thank you again very much for attention. Thank you for your questions. I hope I will see your new retro computer game next time on BalCCon.